Anyway, so we're going to get started right now. I welcome you all to this screencast of research methods. Now, we're going to get into a bulk of research methods. We're not going to talk about statistics, not because I'm afraid of statistics. I actually love statistics, which I might be the only person of the 10 people in this room that might say that, but only because that in itself is a separate presentation. So in this case, research methods, we look at how we do research, how do we do good research, what are the elements of research, what are some mistakes you can make in research, and some of this stuff you've learned in the past in terms of you learned it in science class, you've learned it in basically in different classes, and so it on one hand it might seem a little intimidating, but on the other hand, not really. So what I'm going to do here is, as I go through, if you have questions, please put them in the chat, and I will be happy to answer them. If we get a lot of questions, maybe I'll put the ask a question prompt up. But in the meantime, feel free to just pose questions in the chat. I'll be happy to answer them. I'm an AP Psych teacher, but I am also a moonlighting researcher. I've done research on the side. I've done research projects that I've presented at conferences. I've published papers, primarily in the area of hypnosis. And we're not going to talk about hypnosis. Maybe that'll be a post-exam topic. So basically, the point is that I love experimental design. I love doing research. And so a lot of this kind of just speaks to me in a way. So hopefully my enthusiasm for research methods will kind of spill over, and hopefully maybe you're not ready to be empirical researchers by the end of the evening, but hopefully maybe you'll have a better appreciation of it, and more importantly, more knowledge about the topic. So as most people do in their pod or in their screencast here, I think Fiveable is our handle for Twitter, Instagram, and YouTube. So we're going to start off with some very basic premises here. And I'm actually going to start off with two terms that people tend to use interchangeably, but they shouldn't be. And those terms are a theory and a hypothesis. Theory and hypothesis, some people use them interchangeably. Some people talk about having a theory about something when in fact they might have a hypothesis, and sometimes vice versa. A hypothesis might be a theory. But they're not the same thing, and they are two separate things here that I hope to kind of clarify here. So first off, when we talk about a theory, it's a possible explanation of something, is the way I define it here. Now, if you are into chemistry, or if you're into biology, physics, they don't really care much for the relativity of possible explanation. They tend to be much more, this is what is accepted, this is what we say it is, this is the leading theory, this is what everyone tends to accept unless another competing theory comes in and replaces that. But in psychology, there tends to be sometimes competing theories to explain the same phenomenon. So I use that word possible kind of to illustrate here in terms of psychological research. So to give you an example here, let's see here. Let's suppose I do a study, okay? Or let's say I have a theory, I should say. In this study, I might say people are predisposed to like people they see more often than those they do not, okay? And there is a theory about that. It's actually called the mere exposure effect, where basically the more we see people, the more we tend to like them on balance. We like those who are familiar, that we have seen before, unless there's obviously a reason why we shouldn't like them. But on balance, if we've seen the person before, we might tend to prefer them or like them more than someone that we've never seen before. But we'll call it a theory here that we have some tendency to like people that we see more often or that we're exposed to. Now, on the other hand, you could have a hypothesis, which is a testable prediction of an outcome. And for our case, is a study. Now, I have colleagues who teach biology who don't like the word prediction, but for our purposes here in AP Psych, it's a usable term, it's a usable definition, in so much as because you are going to, if you're doing research, you're testing whether or not a hypothesis, well, first you start with the premise of a null hypothesis, which right now I'm going beyond the scope of AP Psych, but basically say, I think the null is true, that this effect doesn't exist, and you try to disprove that. But the point is that you're trying to test a prediction to see whether or not it's true. So let's say I do a fictitious study, and in this study, so I'll describe this fictitious study to you. So in this study, you enter a room at the beginning of the study, let's say in the morning, and you see 5 people. You see 5 people who you've never met before, but you meet them for the first time. You briefly interact with them, and after about 5 minutes, you all go on your merry way, you leave, and whatever. Later on in the study, you come back at the end of the day. It's now evening. You enter the room. Now there are 30 people that you have never, 30 people that are not friends, people that are more or less strangers to you, although 5 of those 30 are the people that you met earlier in the day. And so in this study, the experimenter sits you down and says, okay, you're about to play a board game, let's say Monopoly. And your task is to pick 5 people that you want to play the game with. And you can pick any 5 you want, doesn't matter. Now, if this theory is true, okay, then I should want to pick those people that I have already met earlier. So in my hypothesis, I think I will say that people will very likely want to play, or more likely want to play with the people they saw earlier. Okay, so in other words, that's a very testable prediction. Either the answer is yes or no. Obviously, there's a big maybe in between, or a kinda, but for our purpose, we can say, give me a criterion, give me some guidelines here, and I can tell you whether or not they met those guidelines and said, yes, this did happen, or no, this did not happen. So that's the hypothesis. I can test it. I can either, for our purposes, I can accept the hypothesis or reject the hypothesis. So there is a difference between the two, okay? But they're not exclusive from one another. You see, a hypothesis can help validate a theory. It can help, if your hypothesis, which is based on theory, is supported, if you basically showed evidence for your hypothesis, then your theory is going to get support for this. But on the other hand, the theory also plays a contribution in that it helps form the hypothesis. So given this, and given this idea that people tend to prefer those they've met before, this helped me generate this hypothesis on the right, that participants will more likely want to play a game with people they have seen before in this particular study. Now, if my hypothesis is not supported, if my hypothesis doesn't turn out to be supported in the study, then this could refute the theory. So if the hypothesis doesn't turn out to be true for our purposes, then the theory might be questionable. And if enough studies do not support the hypotheses, then maybe we have to find another theory. But on the other hand, if we find study after study that shows the hypothesis to be supported, then that will validate the theory and give more evidence that the theory might be correct in this case. So they are two different things. So for our purposes, I would define a theory as an explanation of a phenomenon that tends to be somewhat general, and a hypothesis being a specific prediction of an outcome, and for our purposes, a study. So another thing we're going to talk about here is the difference between basic and applied research. This appeared on a free response question about, I think it was one of the international exams, maybe 6-7 years ago. For example, the time doesn't really matter, but the point was, when would you want to do basic research versus applied research? There was a question about that. And I know if you have the Myers textbook, they kind of gloss over that a little bit. It's not very well delineated between the two. You kind of have to fish one over the other. But basically, let's start with the middle, a knowledge base. When I talk about a knowledge base, it's essentially what we know about something. What do we know about something? Does something work? Does something, what do we actually know about these phenomena in question? What do we know about schizophrenia? What do we know about hypnosis? What do we know about major depressive disorder? What do we know about child development? Whatever we know, that is the knowledge base. So if I do research that adds information to that knowledge base, so for example, I do a study and I find that the average onset of puberty in males is approximately 12.4 years. I'm totally making up these numbers, by the way. That's adding information to the knowledge base. That gives me more information about what I know. But let's say I want to take the knowledge that I have and attempt to solve a problem, or I want to try to make things better in my world. In that case, it becomes what's called applied research. In applied research, here, I'm actually trying to make things better. So if I know, for example, that, say, for example, schizophrenia is due to low levels of dopamine, which we'll learn about in another chapter, then maybe, if this is true, then maybe I should have medications or develop medications that will, in the end, up the amount of dopamine, assuming it's causal, to help alleviate the symptoms of schizophrenia. So understand the difference between basic, where I'm just adding information, getting more knowledge about it, getting more facts about it, which it could be, knowing the average about something. What's the relationship between two variables? Whereas applied research, we really attempt to solve a problem that's there. Okay, so just to remind you, if you want to ask any questions, feel free to do so in the chat. So moving on, I want to talk about now a measure. Now, a measure in this case is anything that could collect data to gauge something, to measure something. I don't like using the word to define itself, but when I have a measure, it could be a survey, it could be a test, it could be an inventory, something that like assesses your personality. A measure is basically any one of those things you might take. You take a "which Smurf are you" quiz on Facebook or on Instagram or something like that. It's a type of measure. So you have these measures here, and you might use them in research. We do use plenty of measures in research. So, but there's a couple of questions you have to ask yourself about. You kind of have a couple of things you have to figure out. For example, what is the operationalization of the measure? Now, operationalization, also known as operational definition, they're kind of used interchangeably, and for our purposes, they are the same. You could kind of say that operationalization is the process of coming up with an operational definition, but for our purposes, it's the same. So an operationalization essentially means, how am I going to measure it? How am I going to measure it? So how am I going to measure something? Let me ask you something. If I'm doing a study in happiness, I'll pose the question here. How can I measure happiness? So how can I measure happiness? Here's a question, okay? What are some ways I can measure happiness? Let's see if there's anyone who wants to contribute an idea. How do I measure happiness? There's many ways I can measure happiness. Some are better than others. Number of times a person smiles a day, good. Or number of smiles per hour, how much they laugh, okay. Could I give a self-reported survey? I could say, how happy are you? Okay, how many times they laugh in a day? Those are all possible operational definitions. Could I say that your measure of happiness is based upon your shoe size? Serotonin, possibly, yeah. Could I say that it's based upon how your shoe size? I'm going to take your shoe size, and that's so I have a no from Annie. What do you think? Catherine says no. Well, it's kind of a trick question. I mean, could I say it? Well, the answer is yes, I could. I mean, I could sit here and call anything my operational definition, but are you going to take me seriously if I say it's an operational definition, or if it's that's my operational definition? No, you're not going to take me seriously, and you definitely should not. You see, there's other issues here involved. Okay, because here's what's interesting to me, at least, when it comes to research. When you see research on the news, often you might get something that sounds very interesting, and it only sounds interesting because the operational definition is kind of defined in a way that you might not expect. If I said, for example, coffee has been linked to better health, and wow, coffee makes you healthier. Well, first of all, there's a correlation causation fallacy, which is a different unit. But let's suppose there's a study that tends to link coffee to better health. Well, one of the questions you should ask is, well, what's good health? It could be, for example, blood pressure. It could be how good do you feel on a scale of 1 to 10. It could be a whole variety of things. I mean, if it was a composite measure put together of all, your blood and hormone levels and your general health, and you put that all together, that's one thing. But if it was like one small thing, like flexibility, let's say, well, you're very flexible if you drink coffee. Again, I'm making this up. You would very much question that operational definition of health. But you see, sometimes that can be misleading. So I have here a headline, a fictitious headline from Monday, September 2nd, 2019 at 12 p.m. The Philadelphia Phillies are tied for first as the greatest baseball team of all time. Now, even if you are a casual fan of baseball, you would know, and you follow the standings, you would know that the Philadelphia Phillies are not exactly showing the greatest play ever. And as of right now, I checked, last time I checked, they were losing badly to the Atlanta Braves. But suppose I say that, okay? Am I lying? Well, maybe not. See, the question you need to ask is, how are you defining the greatest of all time, okay? Could I say the overall win percentage? Well, the Philadelphia Phillies are near last. Actually, they're 26th out of 30th, so it can't be that. Maybe it's their current standing. This is of a couple days ago. Definitely not that. Okay. So then how do I decide? Well, how did I determine this? How did I determine that this is the Philadelphia Phillies are the greatest baseball team of all time? And you're essentially asking, how did you operationally define it? What's your operationalization of greatest baseball team of all times? Well, in my little study, it turns out that at that time, I took the winning percentage of teams over the last 24 hours. Now, as it turns out, the Phillies, among about a dozen other teams, won the only game they played in that last 24 hours. So am I technically correct? The answer is, well, yeah, I am. But is it a very good operational definition? What do you think? Is that a good operational definition, the number of games that you won in the last 24 hours? Of course not, okay? Absolutely not. So it's absolutely lousy. So what you're doing here is that you can say, yeah, you have an operational definition, okay? And yeah, there's a number of problems here. It didn't account for teams that did not play. And one game going to determine the best of all time in a sport that goes back to the 1800s? Clearly not. It's a poor definition, okay? Suppose I ask this question: is the United States the best country in the world? Okay, rhetorical question. The question, though, you have to ask when given a question like that, well, what's your criterion, or what are your criteria for determining the best country in the world? Well, this is actually, I think, from ClickHole. This is great here. United States is ranked 182nd in the world alphabetically. Well, if you're determining the best in the world by your alphabetical order, well, clearly we are pretty much near the bottom. But again, it depends upon the criteria that you use to determine your measurement. How are you going to measure this variable? And that's an important thing, because sometimes it's a very reasonable thing that everyone would say, yeah, that's a good measure. And some would say, no, it's not. Okay, because not only is operationalization important, but is the measure in question valid? Is it accurate? In other words, is the measure an accurate measure of what you intend to measure? So if I step on the bathroom scale, that will definitely tell me my weight, okay? But will it tell me my IQ? Clearly not. So it's valid for one thing, but it's not going to be valid for every other thing. Perhaps, it depends upon what it is I'm trying to measure. So if I give a psychology test, and I say this is going to, or I should say this is going to measure your psychology knowledge of psychology, do your best, and those who score really well on it are going to be good psychology students, or are good psychology students. And as it turns out, they're all questions from AP US history. Now, is that going to be a measure of knowledge in psychology? Of course not. So, sometimes there's always a question of validity here with different things. This is from Ringo Starr's Facebook page. Posted this a number of years ago. So ever take one of those surveys, like which Smurf are you, or which Harry Potter character are you? Ever see those things on social media? What is your Game of Thrones type, or something like that? Perhaps you've seen or inventories like that. So has anyone ever had one of those? Can anyone name a weird one that they had to do or they did? Didn't have to do, but like which blank are you? Could be anything. Like which president are you? Which baseball team are you? Which generation are you from? Well, imagine you were all born in the late 90s, early 2000s. Probably all early 2000s now, I guess. What cheese are you? Hopefully it wasn't Limburger. Okay. So, I mean, you can all think of just these crazy things. Now, Ringo Starr was part of this music group called the Beatles. Maybe you've heard of them. Some say it's the greatest band of all time. I would ask what's your operational definition of greatest band of all time, but okay. He took one of those which Beatle are you was the test that he took. Now, if Ringo Starr, who was a member of the Beatles, takes the which Beatle are you test, he should get Ringo Starr as his answer. Of course, he gets John Lennon, which clearly is not who he is, excuse me. So clearly there was a question with the validity of that measure. That measure was lacking in validity, we would say. So, okay. So validity is another problem or another important issue that we have to be aware of when we do research. And I would say then, of course, another thing is the last thing, which is reliability. When we talk about reliability, the question is the measure in question consistent? Do we have consistent measures? Or does it give you roughly the same result? I step on the bathroom scale, it gives me a number. I step off, I step back on, it gives me a number. It should give me the same number or very close to the same number. If it's not, then it's probably not a not a reliable test. So let's suppose I have here two fictitious intelligence tests, okay? One is called the brand X IQ test, and the one's called the brand Y IQ test. Brand X and brand Y, two totally made up IQ tests. And brand X IQ test, basically people take this test, and these were the average scores over the 6 times it was administered. Okay, here. And then in another part of the study, participants took the brand Y IQ test, and these were their scores. Okay, which of the two has greater consistency between measures? Which of the two has better consistency between measures? Brand X or brand Y? You have a 50-50 shot at this one. So far we have, and basically it appears to be obviously brand X. There's more consistency, okay? Which means that, okay, I had 100 for most IQ tests for our purposes as an average IQ, and it seems like it's hovering around 100, but in brand Y you have ranging from 48 to 172. That's clearly not a very good measure, and that one would have poor reliability. Understand that if a test is not reliable, then it cannot be valid. Because if I step on the bathroom scale and it keeps fluctuating, the weight that it gives me, it keeps fluctuating by 20 pounds, that's a problem because there's no way it can be an accurate measure of my weight if it keeps giving me huge fluctuations in scores. So something can be, if it's not reliable, it's not valid. Okay, so understand that if it's not reliable, it cannot be valid. That's a very important point here. So, okay, questions so far? Again, if you have questions, feel free to put them in the chat, and I'll be happy to answer them as needed. I'm happy to. Okay, so I'm going to move on, and if you have questions, again, please put them in the chat. Next thing I want to talk about is the difference between a population, okay, and a sample. So in a population, when I'm doing a research study, I might be interested in a particular group of people. Now, I could just be interested in any, breathing, warm body human being, or I might be interested in a very specific group of people that I wish to study. The group of people I wish to study is my population. It is the population, it's the group of people I wish to study. I want to know about them. So if I said, for example, I want to study the effects or study the attitudes of teachers from New Jersey about air pollution, okay? So my population, what would be my population in that case? I want to study the attitudes of teachers from New Jersey about their attitudes of air pollution. What's my population? What is my population? It would be indeed teachers from New Jersey. That's correct. Teachers from New Jersey. Not just teachers, teachers in New Jersey. Why New Jersey? I might have some special reason. Now, the problem is that I can't, not easily at least, find every single teacher in New Jersey to take part in this study. It would be next to impossible. Even if I had all the time and the money in the world, I wouldn't be successful in getting every single teacher to participate. So what I need to do is I need to come up with something where I can study that population, even if I can't get everyone in the population to take part. So that's where the sample comes in. I apologize. Didn't realize my picture there was going to cut it off the word. I tried to make sure that didn't happen. But basically, sample, S-A-M-P-L-E, okay? The sample is a representation of the population. It's a smaller group that represents the population. And there's a distinction here. Or I should say there's some very interesting things you should understand about the sample relative to the population. A good sample, okay, should be done by random sampling. And by the way, they love asking questions in the AP exam about this. Random sampling, which means that to find every person in the population has an equal chance of being selected for the sample, or at least given the opportunity to participate. I repeat, I do not want to say everyone in the population is randomly sampled. The reason why I don't want to say that is because if that appears on an FRQ in the writing section of the AP exam and I write that, they'll say I'm parroting the term, and I will not score the point, meaning that I'm taking the term and taking the term and applying it, but not really showing that I know what random sampling means. So I'm giving you a way that could easily score the point, so that if you define it as such, a random sample means that every person in the population has an equal chance of being in the sample, in the study. Now, if I have a good sample that represents the population, then I can make an inference about the population. So in other words, if my sample represents my population, and I find that 30% of the teachers in my New Jersey teachers are very concerned about air pollution, very, very concerned about air pollution, then I can infer, that is, apply or generalize to the population that 30% of the population of New Jersey teachers are also highly concerned or very concerned about air pollution. Now, if I don't have a sample that represents the population, then it'll be difficult to make an inference. So random sampling is one of the best ways to ensure that my sample represents the population. Random sampling is not the only type of sampling that's out there that's acceptable, but it's the one that they often talk about in this course. So you have this sample, okay? And so that actually lends itself to something else here I do want to talk about. So first, remember just that when we talk about samples, samples should be representative of the population. Getting back to validity, because it's going to tie into this idea of sampling. You might have learned about validity and reliability in another class, maybe another science class or something like that. But there's actually two major categories of validity. There's actually more subtypes, but for our purposes, we're going to talk about internal validity, okay, which actually defines the measure assessing what it's supposed to measure. So even though I was actually saying validity means the measure is supposed to measure what it's intended to measure, that was actually internal validity, technically. By its very broad definition, validity means accuracy. So if there's internal validity, it means that the measure generally measures what it's supposed to measure. And again, there's different types of validity, but for our purposes right now, sticking to that. Now, the other type of validity, major type of validity, is the exact opposite. Opposite of internal is external validity. And here's where we kind of get back to our idea of sampling. That when there's good external validity, it means that the sample represents the population. The sample represents the population in question when there is good external validity. And because the sample represents the population, it also means that the results of my sample in my study, so I do this study, okay, and as a result of doing this study, okay, I can take those results and apply them to the population. I can take the results from the sample, whatever I find in the sample, I can apply it to the population because there is good external validity. So it's important to understand the difference between the two types of validity here and how it, especially with external validity, and how it relates to the concept of sampling and making inferences. So in this study that I might do, does the sample represent the population? Okay, yes is good, no is bad. Okay, so hopefully it does. Now, if the sample represents the population, can I make inferences? Can I generalize? Can I apply my sample findings to the population and say what's true of the sample must be true of the population? Well, if my sample represents the population, the answer is yes. If it doesn't, then the answer is no. Well, how did I get that sample? Did I use random? I might have used random sampling to get that good sample. On the other hand, maybe I didn't use random sampling and I had a bad sample as a result. Again, I don't know for sure. So nevertheless, like I said, random sampling is not the only type of sampling. There's other types of sampling, but for our purposes, we're going to stick with that. And finally, if my sample represents my population, that means I can make inferences and generalize my sample findings to the population. I probably used some type of random sampling or something very similar, and I have strong external validity. But on the other hand, if I have weak external validity, I didn't use random sampling, I can't make inferences, I can't generalize, and my sample does not represent my population, that could mess up my data, right? I mean, if I only had teachers in my study from southern New Jersey, that is much different, or could be much different than teachers from northern New Jersey. There is that possibility. And as a result, my data might not be accurate. There might be a skew. It might skew in some way. And we call that, in this case, sampling bias. I apologize. That got broken into two. Missed that there. But it's sampling bias. That G should be sampling bias. Not sampling G bias. It's sampling bias. Again, I apologize for that. But basically, when you have sampling bias, it means your sample does not represent your population. You can't make generalizations or inferences about your population. Your sampling procedure was probably not good, and you have weak external validity. Okay, so all those things kind of come together there. Again, if you have questions, please ask it in the chat, and I'll be happy to answer them as needed. So, all right, moving on. Different types of research, different types of research that are done in psychology. This is not an exhaustive list. There's other things that are done as well, but we're talking about some of the major ones here. First one we're talking about is a case study. A case study gives you a lot of information about a rare or difficult, a rare phenomenon or a rare something to study that you wouldn't be able to study with other types of research. Take, for example, the case of Phineas Gage. Phineas Gage was a mine worker in the 1840s. He was working in a mine, and there was an explosion. And it sent this metal rod through his head, literally through his head, through the behind his chin, through his eye, and out the front of his head. Now, strangely enough, not only did he live through the explosion, he was still conscious when they found him after the explosion. He was still awake. And they put him in a mining cart. They wheeled him up to the town doctor. Imagine being a town doctor and suddenly you see this guy who's awake with a pole through his head. And he was on record saying, "Well, doctor, it looks like you have business for today." So they removed the pole, and he lived for about another couple of years, maybe about 10 years. I can't remember the exact details there. But what they found was there's all sorts of legends and myths about what happened. But essentially, he was, to simplify, he was a little bit more impulsive and irrational at times, just slightly, not much. He ended up being fired from his mining job because, hey, there was no such thing as workers' compensation back in those days. But he lived about another 10 years, and his personality was slightly different. So what does that tell us? It tells us, well, something about the brain or our personality is related in some way to the brain. And you might say, well, duh, I kind of knew that. Well, we didn't know that in 1840 or in the 1840s, okay? So a case study gives you much information about a rare concept. It allows you to study a rare concept. But the problem here is that you don't, or you're not able to generalize very well because your sample size is 1. So there's actually very poor external validity when you do this. There's actually very poor external validity when you do something like this. Doesn't work out very well. All right. But nevertheless, case studies do have their place. Next thing is the interview. This is where you interact with another person. It could be online, it could be in person, over the phone, where you have a conversation or some type of discussion where you try to learn about other people and whatever it is that you're trying to study. Next thing is a survey. Okay, surveys like a questionnaire, questions that are worded in such a way that you might get answers from another person. Observational study, where you are literally observing someone else. You are seeing, you're watching someone either in their natural setting. When I say the natural setting, it means, I don't mean like the forest necessarily, although it could be. But basically, let's say in a place where it's not set up, it's the open world. So for example, I can go to a shopping mall and watch people shop. Like if I'm just sitting in a chair, just watching people go by, making a tally of some behavior, that's a naturalistic observation. Watching the traffic go by. You know, if I sit outside in a street somewhere safely and I watch traffic go by and I'm making an analysis there, is naturalistic observation. The problem is that when I do naturalistic observation, there are so many things I can't control. There are so many variables I can't control. So what do I do to make it, what can I do to control those variables a little bit better? Well, that's where a laboratory study kicks in. In a laboratory study here, you have a setup situation where it has the realistic elements. So for example, if I want to study children and how children play, what I could do is I could go to a playground or I could go to a school, obviously get permissions from the parents and the school administrators to do this type of study. Or I could, let's say I'm at a college or university, set up a big laboratory, convert it into a big playroom, invite children and their parents bring their children, and then they're observed from a two-way mirror or something like that. In that case, I control those things I can't control. Like if, for example, I was out in the playground, it could start raining and my study's ruined. But if I'm inside a laboratory, I can control things like that, so things like that would not happen. So as a result, the laboratory study has advantages, but it also has disadvantages because guess what? I'm in a laboratory and there's going to be a degree of artificiality to it. And it's going to take away from the internal validity, in a way, of the study. So there's pros and cons to each. There's the experiment. The experiment is the only study or the only type of research for our purposes that allows me to infer cause and effect. Does doing A make B happen? And only the experiment allows me to do that. Only the experiment. Can't do that with any other research methods because with an experiment, I am actually controlling something, I am changing something, I am manipulating something in order to see if that change, that manipulation of the variable, affects an outcome, creates a different outcome. Okay, and more on that in a bit. And finally, something called a meta-analysis. Meta-analysis is where I take previous studies and I want to see if there's an overall trend, okay? Now, so I'm not really doing any new studies per se. I'm taking old studies, very old studies, and I'm kind of putting them together to see if there's an overall trend. I'm going to give you an example of this. So again, I apologize, my picture is cutting off the very bottom here, but that says study 12. So let's say 12 different studies were done to assess whether getting a motivational talk, which again is cut off here, again, I apologize, would a motivational talk basically make you pass or help you pass your state's state assessments. I'm sure a lot of you are in a state where you have to do those standardized assessments sometime in the spring, and your school gets evaluated by it, and your teachers get evaluated by it. Just by a show, good, everything's coming in clearly. Oh, good, you can see that. All right, great. I'm just curious, what do you call your state standardized tests in your state? I just want to, in Pennsylvania, they're called the Keystone. So, Vishnu, you don't have to respond to that unless you want to. But what do you call I'm just wondering, what do you call your state standardized tests? Regions, so I was from New York, obviously. Okay. They're very big. The NWEA. Okay. So I'm sure across different states, they are all equally annoying. Although I think in New York, your graduation actually depends upon passing the Regents. Correct me if I'm wrong. Other states, like in Pennsylvania, it doesn't really matter at all. So anyway, called the Florida State Assessment. Okay. Well, let's suppose that in your state, some of you're randomly assigned to either getting a motivational talk or not a motivational talk. The motivational talk means that you're told you can pass the test, you're going to do really well. Well, does that make people pass the test if they get this motivational talk? Well, in study 1, very small difference between the two. Study 2, there was a bigger difference, okay? Study 3, slightly bigger. Let me ask you, are there any studies where the motivational talk clearly outperformed the no motivational talk? Is there something where you can see it was like a really massive difference where the motivational talk between in any of those studies? You look at those studies, look at those percentages. Were there any studies where the motivational talk was clearly superior? Okay, so study 7, that was a 52% difference, 64% versus 12%. Any other study where it was just a massive, massive effect? Where one study or the motivational talk really did better than the no motivational talk? We have study 7 and study 10. Yeah, study 10 is also a big one there. It's about 48%. But on the other hand, are there studies where the motivational talk did worse than those who did not get the motivational talk? So here's the, let's see here. So here's the green to indicate the 2 studies that he did really well. So study 11, the no motivational talk outdid the motivational talk. That was one. And the other studies, and study 5, that's the other one. So, well, what do you make of this? You have 2 studies where there's massive differences, and then 2 studies where it was the other way. So what do you do? Well, if I'm doing a meta-analysis, I could perhaps take the averages. Take the average of this group here, take the average of all these studies here, take the average of all these studies here. And overall, when I put all those studies together, it seems like those who do get a motivational talk, about 50%. Pass their particular key, state assessment, whereas in those who don't get the motivational talk, it's about 38%. Now, meta-analysis are not quite that easy. There's actually a lot more to it, but that's the general idea behind it. So, so the experiment. I'll talk more about the experiment here, okay? Because there's a lot of vocabulary associated with this, and they do ask questions about this in the AP exam. So you have your experiment, which allows you to infer cause and effect. The big disadvantage is that it can be very difficult to design. It can be a very difficult thing to design here. You have those issues there. So, but there's some very important vocabulary here, as I said. The experiment, okay, has variables. And you learned about these probably in science class once upon a time. You learned about the dependent variable and the independent variable. Now, some students still mix up independent, dependent variable, and if I'm not thinking about it, maybe I might mix it up too. The way I would do it, the way I kind of remember it is this. The dependent variable depends on the independent variable. The dependent variable depends on the independent variable. Your test score, whether or not you pass your state assessment, depends on whether or not you got the motivational talk. State test score is a dependent variable. Talk versus no talk is the independent variable. I think depression severity will go down, or the depression severity will change based on whether or not you take an antidepressant. So depression severity depends on whether or not you take the pill. So depression severity is the dependent variable. Whether or not you take the pill is the independent variable. So now the thing is that it gets a little bit trickier because there's a few other variables that are involved here. One is the control variable, so let's say I'm doing my little assessment, my little state assessment study where I'm doing the motivational talk. Some of you get the motivational talk, some of you don't get the motivational talk. What things should I try to keep the same, though? What things should I try to keep the same? So I'm doing this experiment. What other things should I keep the same as best as I can? Or what's like one thing I should probably try to keep the same? What would you say? This is a lot of things. Could be a whole number of things here. So I, for one, might think about it's the same test. Everyone gets the same test. It's the same test severity. Same classroom. All right. Basically, just keeping the rest of the environment as the same as possible. Okay. Another type of variable is called the extraneous variable. Okay, these are extra variables that I can't control, like the age of the participants. It varies. I might have 10th graders, 11th graders, 12th graders, 9th graders. The grade, I can't keep the age exactly the same. I can't make it all 17-year-olds. It probably can't. So those are things I can't control. Now, there are certain things that I can't control that probably wouldn't make a difference. Now, these extraneous variables are variables I can't control. Some won't make a difference. For example, whether or not you like the band Nickelback. Does it vary? Yes. Do you think it's going to matter in terms of this study? Probably not. But nevertheless, it's a variable. But there are some variables that might matter. For example, it could be really hot outside. And it's so hot that kids can't concentrate and they do very poorly on the test. Whatever it might be, and oh, by the way, extraneous variable and control variable are two separate things here. But an extraneous variable that can mess up, this research is called a confounding variable. And the confounding variable can interfere with the influence of the independent variable on the dependent variable. Okay, confounding variables are a type of extraneous variable that can affect the dependent variable that are not the independent variable. To give you a better visual of this, so I have my dependent variable and I have my independent variable, whether or not you get the motivational talk. Hopefully you'll do really well. I'm cheering for you, whatever. There are extraneous variables that are there but probably don't make a difference. But then there are those confounding variables that also affect the dependent variable that are not the independent variable. So maybe my independent variable has no effect. Maybe it doesn't do anything. But due to confounding variables that are not the independent variable, maybe the kids there was a difference between the two groups, and it had nothing to do with the motivational talk. It was a confounding variable. And that's a very important thing to be aware of, because sometimes they happen and you're not aware of it, and it could be a problem. So, all right, and groups in an experiment. So you're doing these groups. You have your control group, and you have your which gets no special treatment, and you have your experimental group, which gets the special treatment. Okay, so control group gets the placebo. They get the waitlist condition. The experimental group gets the drug, the special drug. And here's another important term, that if you have those two groups, there should be random assignment. Because with random assignment, that means every person in the study has roughly an equal chance of being either in the control group or the experimental group. So I already have my sample. This is not random sampling. Random sampling is how I get my sample. Random assignment is what I do now that I have my sample. So I have 100 people in the room. I flip a coin. Okay, you're in this condition. Okay, you're in this condition. You're in that condition. Every person has an equal chance of being either in the control group or the experimental group. Random assignment is a very important thing to do, because if you don't do random assignment, well, that can throw things off very easily. So, We'll talk a little more about random assignment a little later on here, but I also want to talk about ethics in research. Doing the right thing when you do research. You just can't go up to anybody and start doing research, at least not from the perspective of the American Psychological Association, which publishes ethics codes. So a couple of important things to know about research. So one thing you need to have is IRB approval. Institutional Review Board is what IRB stands for, the Institutional Review Board. Went back here. But the Institutional Review Board is a group of people who examine a study, they look at the study, and they make sure it's ethical, okay? Most colleges and universities have some type of IRB to review a study and either give you the okay to do the study or say, no, you can't do the study. So, just checking my Slack here, making sure, okay? The next one is confidentiality. Okay, when we have confidentiality, here we are making sure that the identity of participants is protected. In other words, I'm not going to say that Bob Smith was a participant in my study. I can't describe Bob Smith in such a way that he can be identified. I can talk about Bob Smith's case, assuming I have permission and everything, but I can't say, well, it was a person who lives at this address and has this birth date, because then you could identify Bob Smith. So it has to be something where their identity is protected. Informed consent. Here, this means that we are going to make sure that when a person participates in a study, okay, they know that they're in a study, they acknowledge that the data is being collected. They realize that there could be data that's collected about them. So this is my son, William, who is a confounding variable right now in this podcast. But so whatever it is, I'll get to it later, okay?
Okay.
All right. So.
Oh, it's really short, Dad.
No. I'll talk to you later. So when you have informed consent, it means that you are actually going to agree to be part of the study. So I can't just go up and start doing research on you. You have to acknowledge that it's happening. The only exception to that is in a naturalistic observation, because if I'm in a mall and you're doing something in public and I'm not invading your privacy because you're in the public and I'm not doing anything to you, then informed consent could be dispensed with. But for most other cases, you need to have informed consent. Coercion means that no coercion means that you are freely volunteering, that you are definitely part of the study, freely of your own will, that you're not being indirectly pressured. Like I can't, as a teacher, go to my students and say, okay, I'm going to make my test super duper tough, and if you do, and you're going to fail my class, but hey, if you take part in my study, I'll give you 90% extra credit. That is an indirect form of coercion. Okay. Minimize risks. Okay, this is where essentially that the potential harms of a study, okay, are minimized. And what we usually say here is the potential benefits need to outweigh the risks. That whatever I might get from the study has to outweigh the potential risk. So a drug might have very bad side effects, but it could also cure something, which is very important. Deception, meaning that I withhold information, I withhold something, some information is not going to be released, and because if I do release it, the study will be ruined. But I should only do deception, not to make you look foolish, but only because it's necessary for the study, and any risks that might happen due to the deception are minimized. And whether or not I do deception, at the end of the study, there should be debriefing. When there is debriefing, that means that I am going to essentially tell you everything that was in the study, what happened in the study, what the study was about, if there was deception, you learn about that, what my hypotheses are, all these things, okay? Those are very important things. It's one of those important things you should do is to make sure that your participants know what the study was about, okay? So those are just some of the major things, and they have asked on the FRQ in the past, the written part of the exam, about ethics, and usually knowing these is very, very helpful. I'm going to talk about, and I made a mistake here with this, so I'm just going to put these out here like so. basically, experimenter bias is a threat to validity. So, if I have this great finding, well, is my finding accurate? Is it valid? Well, what are some problems that might happen? One of them is experimenter bias, where as a researcher, I might influence my results. Where, let's say I'm doing a drug study, and I know you get the actual drug and your friend over there gets the placebo, I might treat you a little bit better because you got the drug. And your friend I might not treat as well. I mean, it might not be as, warm and friendly. And that could make a difference right there. It's a type of confounding variable. And so sometimes it's deliberate, which is kind of akin to outright fraud. And sometimes I don't I don't realize that I'm doing it. So to avoid it, I could do a couple of things. One, I could do random assignment. With random assignment, what I'm doing there is just checking my Slack. Okay. Random assignment means that every person has an equal chance, they're already in the study, of being either in the experimental group or in the control group. Okay. And it's done by random. So I'm not going to, if I'm doing that study with motivational talk and your state assessment score, I'm not going to deliberately put all the smart people in the motivational talk and the not as smart people in the non-motivational talks, because that would be clearly a confounding variable. A double-blind procedure is another thing where you don't know if you're getting the drug or placebo, let's say, and I don't know if you're getting the drug or placebo. Okay, someone else will know it. Maybe they'll have a record of it somewhere, but I won't know during the course of the study. So that's a double blind. No one knows the participant assignment, which compares to single blind where you don't know, but I know. And that could be a problem because that can cause experimenter bias. Another issue is social desirability bias. Social desirability bias is where you don't want to make yourself look bad in a study. You want to look good. If I ask you, how friendly are you on a scale of 1 to 10? Well, a lot of people are going to put high numbers. We don't want to say that we're unfriendly. We want to say that there's high numbers or we're very friendly. So it could be rating oneself better than what you might actually be. And a good example is where if you apply for a job and it's one of those personality inventories, you want to make yourself look really good, that's social desirability bias. Another example of social desirability bias is if they're asking your knowledge about a TV show and you don't want to say, well, I've never seen it before. So sometimes you pretend like you've seen this TV show. Well, clearly, now you're talking about a TV show that you've never seen before because you don't want to look foolish in that you have never seen that show before, or by saying you've never seen that show before. So that's social desirability bias. Another one is the placebo effect, where it's associated with the fake pill, or the fake treatment, or the fake therapy. That combined with the expectation of healing can actually produce a healing response. And it's actually a very powerful effect. It's remarkably powerful. It works remarkably well in terms of how effective it can be. Basically, one study, a very famous study, was done where participants were given a morphine pump. They were post-surgical procedure where they're in a lot of post-operative pain, and they're given a morphine pump where they can, within a certain range, pump enough morphine to alleviate their pain. And in some conditions, they could see the machine that was pumping it, and in other conditions, they could not see it. And what they found was that when they could see the pump, they actually administered less morphine. Why? Because when they hit the button, the machine activated, and that actually activated the healing response. So that's the placebo effect. So really, in a way, every study that you do has some type of placebo effect to it. Okay, even drugs, every drug, every therapy has some placebo to it. The question is, how much more effective is the drug on top of the placebo? That's the question there. That's what they're very interested in. Okay. All right. And finally, the Hawthorne effect. The Hawthorne effect is knowing that you're being observed. Knowing that you're being watched in a study can actually bring out a better behavior. You perform better because you know you're in a study, you know you're being observed. This was named after a study in Hawthorne, New Jersey, at a factory. It was actually a very big, elaborate study where it was a number of different things that were being researched, but basically they kept playing with the lighting. Those brighter lighting or dimmer lighting produce more worker productivity. And they found that no matter what they did, with the exception of very low levels of light, productivity went up. Why did productivity go up? Productivity went up because they knew they were being watched. They knew they were being studied. They knew something was changing. And so, hey, I'm going to give you what you're looking for. So the Hawthorne effect is one of those things that can threaten validity. You think, wow, the lights, if it's brighter, it makes you more productive. Well, maybe that's just the Hawthorne effect. Okay, so with that, I'm going to answer any questions. Any questions you want to know about, anything about research? Again, I'm not going to get into statistics here, only because that's a whole nother 12 hours. I'm just kidding. It'll be a whole nother screencast. But any research questions, anything you want me to talk about? And I'm not going to say that I've covered every single thing that's in the research unit, but I did cover a good bulk of it, I would say. Any questions that you want me to answer? Anything that you would like me to go over or elaborate on, or anything you want me to explain in greater detail? Anything at all? I know it's 9 o'clock here on the East Coast, and maybe some people have dozed off. I hope not, but so any questions at all? Give an example of a random sample. Sure. So, good question. In a random sample, let's say I go to a high school and I want to sample, I want to do a study with the high school students that are there. And obviously I can't sample I can't, get everyone in the population, so I take a sample. It could be as silly, although a valid example, of taking everyone's name and put it into a very big hat and selecting 100 names. It could be, let's say you have school ID numbers that are like a 10-digit number, let's say. I can use a random number generator to select student ID numbers, and when I get matches, the first 100 that pop up will be my sample. I could give everyone an envelope in the school, and if they open up the envelope and it says, "You've been picked," and they're handing out randomly, that could be a random sample. So names in a hat is a classic example that could score you the point if it's on an FRQ. Random number generator, everyone gets a number randomly generated, and if it's the numbers 1 through 100 get to be in the study. So that's an example of random sample, or how to do a random sample. You're welcome. Qualitative research. So when you do qualitative research, here it is in a nutshell. What you're doing here is you're not really collecting numerical data per se. It's more descriptive data. Now, you can do descriptive data with numbers, but so let's say in an interview, I want to know about what you think about state standardized exams. Now, quantitative data might be on a scale of 1 to 10, how much do you like state standardized exams? On a scale of 1 to 10, how much do you like to prepare for state standardized exams? Qualitative data, on the other hand, is where what I try to do here is I say, okay, tell me about your attitudes. You say, well, I hate it. Okay, well, the person says they hate it. Whenever I get a state standardized exam, I like to fill in the bubbles. Okay, doesn't take it seriously. So I'm writing descriptions. Now, I could down the road quantify that, but for our purposes, qualitative data usually involves counting actual numbers, giving values to things, whereas qualitative is more of a description that doesn't, you kind of have to use words to illustrate, to kind of elaborate on. So that's the qualitative research in a nutshell. So good question. Other questions? You're welcome. My pleasure. Other questions? There's also something called mixed methods, which I don't think would be on the AP exam, but basically it's quantitative and qualitative put together. Most studies really, in theory, are mixed methods, but whatever. But qualitative is like description, and quantitative is numbers. So, other questions? All right. All right. Well, let's see here. Seeing that, I'm going to stop sharing this Chrome tab here. So now it's just me. Okay. So I thank you very much for showing up this evening. Remember, at ThinkFiveable for Instagram, for Twitter, and for YouTube, so you can follow along, get updates, see when the next streams are in AP Psych and other topics. So it was a pleasure being here. I hope I gave you some good information to work with. And make sure when you come to future streams that you have questions, that you have anything you need to know, because we're here to help you get ready for this exam. And AP Psych is May 12th, which seems like a very long time away, but trust me, it will be, I believe, 8 months this Thursday, and it comes very, very quickly. So be prepared. Thank you for showing up, and I wish you all a very pleasant evening. Take care.